Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Students, let us solve question number 14, NEET Physics paper 2015. Students, let us solve question number 14. A rod of weight W is supported by two parallel knife edges A and B in equilibrium in a horizontal position. The knives are at a distance D from each other. The center of mass of the rod is at a distance x from A. The normal reaction of A is. There is a rod whose weight is W, is supported by, so obviously its weight will be from hanging downward from its center of mass, supported by two parallel knife edges A and B, and is in equilibrium in a horizontal position. So this is supported by two knife edges. The knife edges are at a distance D from each other. So where these knife edges are placed not given, I will put one knife edge over here, another knife edge over here, and the distance between the two knife edges is D. The center of mass of the rod is at a distance, center of mass of the rod, this is center of mass of the rod, is at a distance x from A. If I consider this as A, this as B, two knife edges, then from A the center of mass of this rod is at a distance x from here. If this is x, then obviously this distance will be D minus x. Then you have to find the normal reaction on A. On A at this point, what is the normal reaction? So question is to find the normal reaction on A. I call it NA. So what you have to find what is NA. First of all, let us draw the free body diagram or all the forces acting on the system. This knife edge is supporting this, so normal reaction will act in this direction, that is your NA. Here also there is normal reaction, that is N of B. One weight is the center of mass will go down, the weight will go down from here to the center of mass, and there are no other forces, they are in equilibrium. So because they are in equilibrium, right, the upward force and downward force will balance each other out. So the normal reactions Na plus Nb together is balancing the weight of the rod. This is my equation 1. And our aim is to find Na. We are not interested in Nb, but we can write the answer in W because that is the given in the question, and the options also we have got W. So W can be used, but Nb is not required. This is the force equation. Net force is 0. Similarly, for equilibrium, this is F net is 0. Similarly, for equilibrium, the net torque should be 0. As the rod is in equilibrium, the net torque on the rod is 0. The clockwise and the anti-clockwise will balance each other out. If I see this one, the weight is this one, so about which point I want to find the torque. If net force is 0, I can, because I don't want NB, so I will consider this point, and about this point B, about point B, I want to find the torque about B, because if I want to find the torque about B, then the torque contribution due to this normal reaction will be 0. We know that if any force passes through the point about which you want to find the torque, then that force will have no turning effect, or torque due to that force passing through that point of rotation will be 0. Therefore, I will consider the point B and try to find the net torque about this point. So in that case, I have got only two forces acting. This will try to rotate in anti-clockwise sense, and this force will try to rotate in clockwise sense about this point. So this rod will be rotated clockwise and anti-clockwise sense respectively by this and that about this point B. So these two will balance each other out. Here the clockwise torque, because of NA, is NA, this force, and this perpendicular distance. That is the formula for torque. Formula for torque is, about any point, is the force and the perpendicular distance. This is the force, this is the line of action of the force, and this is the perpendicular distance about this point of rotation. And this distance is obviously d. So NA into d, which is clockwise torque. So torque about point B due to NA and W is given by, so torque due to NA must equal to torque due to W about the point B. The torque due to NA is the normal reaction about A into the perpendicular distance, that is d, must be equal to this weight, that is W, and this distance, that is d minus x. So therefore this must be W into d minus x. So from here I'll write NA equals to W d minus x, this one divided by d. So the normal reaction at the knife phase A is given by W d minus x over d. The question is to find the normal reaction on A. The normal reaction on A is found to be W d minus x by d. W d minus x by d, this is not d, W d minus x by d. So this is the right answer to this question. Okay, thank you.